Pluto was supposed to be the end of the solar system story. Instead, the James Webb Space Telescope has found a world that refuses to die. For decades, Pluto appeared to be nothing more than a tiny frozen dot, too small, too distant, and too cold to matter. Then NASA's New Horizons spacecraft flew past it, revealing mountains of ice, a giant heart-shaped plain, a blue atmospheric haze, and signs of surface activity that no one expected. But New Horizons had only one opportunity, one flyby, one brief glimpse. Now, James Webb has looked back at Pluto with its powerful infrared eyes, and what it found is even stranger. The haze surrounding Pluto's atmosphere may be acting like a planetary cooling machine. The implications extend far beyond Pluto itself. Webb's observations suggest that the chemistry and climate of distant icy worlds can be far more complex than scientists once believed. Pluto's haze forms through chemical reactions involving methane and nitrogen, and researchers believe it may provide clues about hazy worlds such as Triton and Titan, and even conditions that existed in Earth's early atmosphere. That means Pluto is not simply a frozen leftover from the formation of the solar system. It may be a natural laboratory where sunlight, ice, atmospheric haze, and organic molecules have interacted in darkness for billions of years. And if Pluto can conceal this much complexity, what other mysteries are waiting in the Kuiper Belt? For decades, Pluto was treated as the solar system's forgotten world, too small to matter, too distant to understand, and too cold to change. Viewed from Earth, it was little more than a faint point of light drifting slowly across the background stars. Astronomers knew where it was and how it moved, but they did not truly know what it was. Was it simply a frozen rock, a lifeless ball of ice, a planet, or perhaps a mistake? For much of the 20th century, Pluto remained more mystery than world. Then came the historic vote. In 2006, Pluto lost its status as the ninth planet. For millions of people, that felt like the end of its story. Pluto had been discovered, celebrated, reclassified, and pushed to the edge of scientific attention. A small frozen object orbiting far beyond Neptune, seemingly with nothing left to reveal. But that idea did not survive humanity's first close look. In July 2015, NASA's New Horizons spacecraft finally reached Pluto after traveling through space for nearly 10 years. It could not slow down or enter orbit. It had only one chance, one flyby, and one narrow window to collect as much data as possible before continuing deeper into the Kuiper Belt forever. Scientists expected surprises, but nothing like what they found. Pluto had towering mountains, not small hills, but real mountains made of water ice so cold and hard that it behaves almost like rock. It had an enormous pale heart-shaped region stretching across its surface, smooth and surprisingly young compared to the heavily cratered terrain surrounding it. It also had vast plains of nitrogen ice that appeared to be slowly moving, shifting, and churning over time. Above it all floated a blue atmospheric haze, layer upon layer rising high into Pluto's thin atmosphere and glowing beautifully whenever sunlight passed behind the dwarf planet. That was the moment Pluto stopped looking like a dead world. Dead worlds do not usually have surfaces this fresh. They do not normally show evidence of movement, nor do they surround themselves with complex atmospheric haze and unusual chemistry. Pluto was no frozen ending. It was an active and fascinating world hidden at the edge of the solar system. Yet New Horizons faced one unavoidable limitation. It was moving far too fast. The spacecraft collected its data and continued its journey into deep space. There would be no second pass, no return mission, and no opportunity to watch Pluto change over time. Humanity received one breathtaking glimpse, and then Pluto became distant once again. 4 years afterward, the mystery remained. Scientists had the photographs, the maps, and the first close-up clues, but they still needed answers about Pluto's atmosphere. They wanted to understand its chemistry, its temperature, its haze, and the processes shaping its climate. That was no easy task. Pluto lies nearly 4 billion miles from Earth. It is incredibly faint, extremely cold, and appears close to its large moon, Charon, making its weak thermal signal difficult to separate. Earlier telescopes struggled to isolate Pluto clearly enough because the signal was simply too faint and too easily mixed with surrounding light. Then the James Webb Space Telescope turned its attention toward Pluto. Unlike New Horizons, Webb did not fly past the dwarf planet or hover above its surface. Instead, it accomplished something remarkably different. From billions of miles away, Webb studied Pluto's infrared light, the invisible heat radiation that human eyes cannot detect. Hidden within that faint glow was a discovery that changed Pluto's story once again. Webb found evidence that Pluto's haze is not merely a beautiful blue layer decorating the atmosphere. It plays a fundamental role in controlling the planet's climate. At first, the discovery seemed almost impossible to explain. On many worlds, atmospheric haze traps heat like a blanket, warming the air below. Pluto appears to do exactly the opposite. Its haze behaves like a giant radiator. It absorbs the weak sunlight reaching the distant dwarf planet, and then releases that energy back into space as infrared radiation. Instead of warming Pluto, the haze actually cools it. In other words, this tiny dwarf planet in the deep darkness of the outer solar system seems to operate its own atmospheric refrigerator. That remarkable discovery makes Pluto even stranger after James Webb's observations than it was after the historic flyby of New Horizons.